Hello, David Hyatt here. Welcome back to Fast Pace. The subject of this program is brakes. While researching this program and talking with technicians in the field about brake servicing, we did find the quality of actual service work to be very, very high. However, we found some confusion about proper terminology and vocabulary. You know, maybe that's why there's such reluctance on the part of you technicians to taking tests in general. So with this in mind, we've geared this whole program to address and clear up as much terminology on the subject as time permits. So you might find the pace of this video pretty fast. If you can keep up, great. But if you miss something, remember your VCR has a rewind button, so use it. To maximize the benefits of this program, stop the tape and take the brake mini test. Then return to this tape for clarifications of the questions you had problems with. The mini test and the answer sheet are in your support package. Well, how did you make out on the mini test? Did you notice that there were no questions on basic theory of operation of the hydraulic brake system? Or for that matter, there were no questions on the more common brake service procedures such as bleeding the brakes or drum and disc resurfacing. We've made the assumption that you understand these procedures completely from day-to-day exposure in your shop. Now, if you're not 100% sure that you know these procedures correctly, please see the task sheets included with this program. We'll concentrate the majority of our efforts in this program on the content areas of hydraulic system diagnosis and repairs, disc brake diagnosis and repairs, and drum brake diagnosis and repairs. Let's begin with the hydraulic system. A customer states the brake warning light comes on. Technician A says that a faulty parking brake switch could be the cause. Technician B says that there may be uneven pressure in the brake system. Who's right? A only. B only. C, both A and B. D, neither A nor B. In this question, we must determine if each statement is true or false. We know that a parking brake switch will turn on the brake warning light, so Technician A's statement is true. This narrows the possibilities to response A or response C. Now, because there's more than one switch that can turn on the brake warning light, it is also possible for Technician B's statement to be true. Let's take another look at Technician B's statement. Uneven pressure in the hydraulic system will cause the pressure differential switch to turn on the brake warning light. If pressure is low in one of the two brake systems due to air or to a fluid leak, when the brake pedal is depressed, the normal pressure in the other system will push the differential piston toward the side with lower pressure, thus grounding out the internal switch. This turns on the dash warning light. On most models, this piston is spring balanced, so the piston recenters as the brake pedal is released. This, in turn, turns off the warning light. On some older models, if a failure occurs, the piston will remain off-center, and the light will remain on even when the pedal is released. After repairs are made, the valve has to be reset by manually removing the switch assembly to allow the spring-balanced piston to recenter. So you can see that Technician B's statement is also true. This eliminates response A for A only. So, response C is the correct answer. When bleeding front disc brakes with a pressure bleeder, A, the proportioning valve must be held open. B, the metering valve must be held open. C, the pressure differential valve must be held open. D, none of the above. The metering valve allows approximately 100 pounds of pressure to be applied to the rear wheels to overcome return spring pressure before allowing pressure to be applied to the front disc brakes. This provides even braking between the front and rear wheels. When pressure bleeding the system, approximately 20 pounds of pressure is used. Now, this is not enough pressure to overcome the metering valve. So, in order to properly bleed the system, the metering valve must be held open when pressure bleeding front disc brakes. So the correct answer is response B. All of the following will cause a vehicle to pull to one side except A, worn suspension parts, B, contaminated brake linings, C, air in the system, D, frozen brake caliper. Because of the word except, we must look for the response that will not cause a vehicle to pull to one side. Anything that results in one wheel stopping more or less than the rest can result in a wheel pull. Air in the system affects all the wheels. So, C is the correct answer. The residual check valve, A, maintains a slight pressure in the line on drum brakes, B, prevents air from entering the wheel cylinders, C, is only used on disc brakes, D, both A and B. The residual check valve in the master cylinder maintains a slight residual pressure of approximately 6 to 20 psi in the line when the pedal is released. It's only used on drum brakes. Its purpose is to take up the slack in the brake linkages and also keep the wheel cylinder seals tight against the wheel cylinder housing, thus preventing fluid from leaking out and air from leaking in. The brake shoe return springs, which are capable of exerting approximately 50 psi, overcome the residual pressure and prevent the shoes from dragging. If a residual check valve was inadvertently used on disc brakes, they would drag. So the correct answer is response D. The rear wheels on a vehicle with front disc brakes tend to lock up on hard stops, especially on wet roads. What could be the cause? A, a faulty metering valve, B, a faulty proportioning valve, C, an inoperative pressure differential switch, D, any of the above. To answer this question, you must understand the function of each component mentioned. The metering valve allows approximately 100 pounds of pressure to be applied to the rear brakes before allowing pressure to be applied to the disc brakes. This allows the rear drum brakes to overcome the return spring resistance so that, in reality, both the front discs and the rear brakes are applied at the same time. An inoperative metering valve would cause the front brakes to lock up. A pressure differential switch turns on the brake warning light when there's a pressure difference between circuits of a dual master cylinder. A defective pressure differential switch would not cause the rear wheels to lock up. A proportioning valve reduces the pressure to the rear brakes on hard stops. During a hard stop, vehicle weight is shifted to the front of the car. The front dips as the rear lifts. This is especially true on front-wheel drive vehicles, which already have a majority of their weight over the front wheels. During hard stops, the rear brakes tend to lock up. When pressure in the rear brakes get to a predetermined level, the proportioning valve limits the amount of pressure to the rear brakes. This helps to control rear wheel lockup. So if the proportioning valve fails, the rear wheels could lock up. The correct answer, therefore, is response B. For this question, refer to the corresponding graphic on your mini-test. The component shown is A, a combination valve, B, a metering valve, C, a pressure control valve, D, none of the above. The correct answer is response C, a pressure control valve. The pressure control valve performs the same function as a proportioning valve. However, it is mechanically connected to the rear axle. As the rear of the vehicle raises during hard stops, the valve reduces pressure to the rear brakes. This valve is more accurate than a proportioning valve because it can compensate for vehicle weight changes. If the rear of the vehicle had a lot of extra weight in it, there'd not be a need to reduce the pressure to the rear of the vehicle. When a vehicle with a pressure control valve is on a lift with the rear wheels hanging, it'll be difficult, if not impossible, to bleed the rear wheels. You must first disconnect the valve arm from the axle or support the rear axle assembly before bleeding the rear brakes. A combination valve may contain A, a metering valve, B, a proportioning valve, C, a pressure differential switch, D, any of the above. A combination valve is a single component that may contain any of the above valves or switches. For example, a combination valve on one vehicle may contain a metering valve and a pressure differential switch, while a combination valve used on another vehicle may contain a metering valve, a proportioning valve, and a pressure differential switch. So the correct answer is response D, any of the above. All the brakes on a vehicle are dragging. Technician A says a misadjusted master cylinder pushrod could be the cause. Technician B says a misadjusted brake stoplight switch could be the cause. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is true. The pushrod that activates the master cylinder must be properly adjusted. If the pushrod is adjusted too short, there will be excess pedal travel. If it's adjusted too long, the brakes will drag. Technician B's statement is also true. If the stoplight switch is adjusted too far in, the brake pedal will not return to its rest position. In effect, it will hold the brake pedal down, causing the brakes to drag. Therefore, the correct response is C. A brake line is leaking. Technician A says to repair it with a compression fitting. Technician B says to replace it with a piece of copper tubing. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is false. Brake lines should always be replaced if they're damaged. Technician B's statement is also false. Brake lines should never be replaced with copper tubing. Most brake lines are double-walled steel that are coated to resist rust and corrosion. The correct answer is response D, neither A nor B. Technician A says that brake fluid with a cloudy appearance indicates contaminated brake fluid. Technician B says that brake fluid that is very dark indicates contaminated brake fluid. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is true. Brake fluid which is contaminated with moisture becomes cloudy in appearance. This greatly reduces the boiling point of the fluid. Technician B's statement is also true. Brake fluid which is very dark in color indicates the fluid is contaminated with rust or another foreign liquid. If a vehicle with contaminated brake fluid is encountered, always flush the brake system with fresh brake fluid from a sealed container. The correct answer is response C. Whenever cleaning wheel cylinders, master cylinders, or other hydraulic brake parts, always use A, carburetor spray, B, kerosene, C, gasoline, D, alcohol. Use of carburetor spray, kerosene, or gasoline will ruin brake parts. Whenever cleaning hydraulic brake parts, always use denatured alcohol or clean, fresh brake fluid. The correct answer is response D, alcohol. . While holding steady pressure on the brake pedal, the pedal slowly sinks to the floor. There are no external leaks found in the vehicle. What's the most likely cause? A frozen brake caliper piston. B, an internal leak in the master cylinder. C, defective proportioning valve. D, weak brake return springs. Response A, a frozen brake caliper piston, will cause a hard pedal, not a sinking pedal. Response C, a defective proportioning valve, will not cause the pedal to sink to the floor unless it is externally leaking. Weak brake return springs, as stated in response D, will cause the brakes to grab. Response B, an internal leak in the master cylinder, will cause a pressure loss. As pressure drops, so will the pedal. So response B is the correct answer. A vehicle with rear drum brakes is being road tested. The brake pedal pulsates when the brakes are applied. The parking brake also pulsates when applied while driving. This indicates A, a rear drum could be out of round. B, a rear axle could be bent. C, both A and B. D, neither A nor B. In this example, the problem is narrowed down to the rear of the vehicle. A brake drum that's out of round could cause the brakes to pulsate. So response A is true. A bent rear axle, as indicated in response B, will cause the drum to wobble, which will also result in a brake pulsation. Therefore, the correct answer is response C, both A and B. For this question, refer to the corresponding graphic on your mini-test. In the illustration shown, the marking on the brake drum indicates A, the maximum outside drum diameter before resurfacing, B, the maximum outside drum diameter after resurfacing, C, both A and B, D, neither A nor B. Now don't forget, read the responses very carefully. At first glance, response B seems to be the correct answer, but the marking on the brake drum indicates the maximum inside, not outside, diameter of the brake drum after resurfacing. So the correct answer is response D. Upon inspection of the rear brake shoes, it's discovered there's gear oil on one set of brake shoes. The linings have 80% of their brake material left. Technician A says to check for a leaking axle seal. Technician B says to spray the brake shoes with carburetor cleaner to remove the gear oil. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is true regarding a possible leaking axle seal. Technician B's statement is false. You should never attempt to clean oil from brake shoes. The brake shoes should be replaced. Only Technician A's statement is true. So the correct answer is response A. Technician A says that weak return springs on drum brakes can cause grabbing brakes. Technician B says that weak hold-down springs on drum brakes can cause a spongy pedal. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is true. Weak return springs can cause the brakes to grab. They can also cause the brakes to drag. Technician B's statement is false. Weak hold-down springs will cause the brakes to grab also, but will not cause the pedal to be spongy. So the correct answer is response A. For this question, refer to the corresponding graphic on your mini-test. Referring to the illustration shown, all of the statements are true except A, the brakes are self-energizing. B, Component X is used to center the brakes. C. Component Y is a brake hold-down spring. D. Component Z is for the self-adjusting mechanism. In this question, we're looking for the response that's false. The brakes shown in this illustration are self-energizing. As the wheel cylinder pushes the brake shoes against the brake drum, the shoes try to rotate with the drum. This wedges the larger rear brake shoe into the brake drum, increasing the stopping force. So response A is true. Component Y is the brake hold-down spring, and component Z is the cable for the self-adjusting mechanism. So responses C and D are true. Component X is used to apply the parking brake, not to center the brakes. So response B is false. Therefore, the correct answer is response B. For this question, refer to the corresponding graphic on your mini-test. Technician A says the tool shown may be used to adjust drum brakes. Technician B says the tool shown may be used to check for out-of-round brake drums. Who's right? A only, B only, C, both A and B, D, neither A nor B. Technician A's statement is true. After replacing brake shoes, this tool is used to measure the approximate drum inside diameter. The brake shoes are then adjusted to match. Technician B's statement is false. While this tool looks like it would work for checking brake drums for out of round, it doesn't provide an accurate measurement. The correct answer is response A. For this question, refer to the corresponding graphic on your mini-test. In the illustration shown, which component is not installed correctly? A, the wheel cylinder cups, B, the wheel cylinder pistons, C, the spring, D, the dust boots. The wheel cylinder cup, spring, and dust boots are installed correctly. The pistons are not. The indentations in the pistons are seats for the push rods, which should face toward the outside. The correct answer is response B. The most likely cause of an out-of-round brake drum is A, dirt that accumulated in the drum, B, excessive parking brake force, C, overheating of the drum, D, using semi-metallic brake shoes. Brake drums become out of round from excessive heat. Heavy brake usage, a drum which has been cut too thin, and dragging brakes can all allow the drum to become too hot. The correct answer? Response C. Technician A says that a micrometer is used to check rotor parallelism. Technician B says that a dial indicator is used to check rotor lateral runout. Who's right? A only, B only, C, both A and B, D, neither A nor B. In this example, we must determine if each statement is true or false. Parallelism refers to variations in the rotor thickness. A micrometer is used to measure thickness. So Technician A's statement is true. Lateral runout is the wobble or side-to-side movement present in a rotor. This is measured with a dial indicator. So Technician B's statement is also true. The correct response, C. One brake pad is worn much more than the other on a single piston disc brake caliper. What could be the cause? A, a frozen caliper piston, B, excessive rotor parallelism, C, loose wheel bearing, D, caliper assembly stuck, that is, not free floating. To answer this question, you must understand how a single piston disc brake caliper operates. Instead of having one piston for each brake pad, a single piston applies pressure to one pad. The caliper assembly floats freely. When pressure is applied by the piston, this pushes the brake pad against the rotor. When contact is made, the caliper moves with an equal force until the other brake pad contacts the rotor. If the caliper assembly was stuck, only one brake pad would wear. The correct response, D. A customer with power brakes states that if he depresses the brake pedal and starts the engine, the pedal drops slightly. Technician A says this is normal. Technician B says low engine vacuum may be the cause. Who's right? A only. B only. C, both A and B. D, neither A nor B. Technician A's statement is true. The brake pedal will drop slightly when the engine is started. It's characteristic of power brakes. If the pedal did not drop, it would indicate a problem. Technician B's statement is false. Low engine vacuum will cause a hard pedal or lack of assist. The correct answer is response A. A parking brake will not hold a vehicle on a hill. Technician A says the parking brake cable may need to be adjusted. Technician B says there may be air in the rear brake lines. Who's right? A only. B only. C, both A and B. D, neither A nor B. Technician A's statement is true. The parking brake mechanically applies the rear brakes. In most cases, when it doesn't hold, the parking brake cable usually needs adjusting. Even if there was a malfunction in the brake hydraulic system, the parking brake would still operate. Technician B's statement is false. Air in the brake lines would affect the hydraulic system and would have no impact on parking brake operation. The correct answer, response A. On the Tevez anti-lock brake system, Technician A says that on most vehicles you must discharge the accumulator before checking the brake fluid level. Technician B says that if the fluid level is low, you should always add .5 brake fluid. Who's right? A only. B only. C, both A and B. D, neither A nor B. Because Technician A used the phrase on most vehicles, his statement is true. On most vehicles, you do check the fluid level with the accumulator discharged. But always check the label on the fluid reservoir to be sure, because there are some vehicles in which you check the fluid level with the accumulator charged. Technician B's statement is false. Although most vehicles with Tevez anti-lock brakes recommend .3 brake fluid, there are a few vehicles that recommend .5. Our technician, however, stated that you should always use .5. The correct answer, therefore, is response A. The questions covered in this video were carefully selected to cover as many tasks as possible. Now remember, if you're still unsure about some of the techniques, the terminology, or the systems we discussed, review the task sheets accompanying this program and obtain some of the related training material listed on your reference sheets. Good luck with the test.